Hi folks, this is question 9. So it's an interesting enough kind of start to the question. So list the 5 different factors of 2 to the power of 4. So we know 2 to the power of 4 is 16. So you know that the factors are 1, 2, 4, 8, and 16. Then you need to give them as 2 to the power, okay? So, but you could just go and do it as 2 to the power from there if you want. But you might be able to realize first of all that 2 to the power 1, it'll just be 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 3, and 2 to the power 4. They're the factors, so they're the 5 factors. So you may be able to spot that straight away, but if not, you can get back around to it. So then work out how many different factors 3 to the power 7 has. So in this one up here there was 5 different ones, and it was all of those. So here it has to be 8. So it's just going to be 3 to the power 0, 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4, 3 to the power 5, 3 to the power 6, and 3 to the power 7 itself is a factor of itself. So that's all you have to do for those two parts. Work out how many different factors for 2 to the power 10 multiplied by 3 to the power 12. Right, so for this then you can use what we kind of had in the last part. So 2 to the power 10, that has to have 11 different factors. So 2 to the power 0, 2 to the power 1, 2 to the power 2, up to 2 to the power of 10. And then 3 to the power 12 has to have 13. So what you have to do with these two things then is multiply them, because each set of factors will be individual. So you're going to get 143 altogether when you multiply those two. Right, so part B then, first part is easy enough. You're just looking for two numbers to give you that multiply to give you 12. So 1 has to be multiplied by 12 to give you 12. 2 has to be multiplied by 6. 3 times 4, then 4 times 3, the reverse, and then 6 times 2, and then 12 times 1. So that's nice and easy. Plot the 6 points above on the coordinate diagram below. One of the points, yeah, I just have that taken out twice. Right, so first one was 112. That's there. 2 times 6, so 2, 6. Then 3, 4 is there already for us. Just make it a bit bigger. 4, 3 will be here. Then 6, 2 is here. And then 12, 1 is here. We've got them all there. 1, 2, 3, 4, 5, 6. Yes, that should be it. That's all you have to do. They're nice, easy marks. They're marks everybody would have got, or almost everybody. So Ava realizes that the relationship between x and y is y equals 12 over x. On the coordinate diagram above, draw the graph of y equals 12 over x. Right, so all you're really doing here is just connecting up all the dots. So this is the graph of y equals x, or 12 over x. So I should have used a different color really. It should be something like that. So a tangent to the curve is drawn at the point P 12 over P. Right, so we're going to be using the y minus y1 equals m by x minus x1 formula. So we're looking for the equation of the tangent. So there's a tangent at some point. So obviously the thing we need to work out first is the slope of the tangent. So to work out the slope of a tangent, you differentiate. So y equals 12 over x. So therefore dy dx is equal to, well, that's the same thing as 12x to the power minus 1. So multiply by the power, so it'll be minus 12x to the power of minus 2. And that's the same thing as minus 12 over x squared. So we can put that in then with the x1, y1. So y minus 12 over p is equal to, that's minus 12 over p squared. Sorry. No, we're right. Yeah, so x. So I'm just putting p in. So x minus and then x1 is just p. So we get y minus 12 over p is equal to minus 12x over p squared plus, because minus times minus, just 12 over p, because one of the p's cancels out. And then minus 12. Yeah, so we just have to bring the minus 12 over p over to the right hand side. So we get minus 12 over p squared, minus 12x over p squared, plus 24 over p, because you're just adding the 12 and 12 together, because they have the same denominator. So we've shown that then. Right, so for the last part here, we want to do half times base times height. Right, so the height anyway, because it's a bit easier to find, I think. The height will be where it crosses the y-axis, therefore x has to be 0. So I'm going to sub 0 into that equation. So y is equal to minus 12 over p squared times 0 plus 24 over p. Yeah, so see the way the minus 12 over p squared, that'll just go. So y is equal to 24 over p. So 24 over p, that's the base anyway. The height then be a little bit harder, not much, same thing we're doing, but now we're subbing in y equals 0, because everywhere on the x-axis y is 0. So we get 0 is equal to minus 12 over p squared plus 24 over p. So bring it over to the other side. 12 over p squared is equal to 24 over p. 12p is equal to 24p squared. You can divide both sides by 12p there. So you get 1 is equal to 2p. 1 is equal to 2p. Is that right? Oh no, I left out the x. I was wondering. Yeah, it should be an x there beside the 12. So here 12px. So we get x there instead of 1. So x is equal to 2p. Just get rid of that. So we get x is equal to 2p. So that point there then, down here, this is the point 2p 0. So therefore our height, oh no, I mixed them up. Yeah, it'll be 2p. So base is 2p and height is 24 over p. So we're just multiplying those things together. So half times 2p times 24p. Right, and then so things will cancel out here. So the p's will cancel out, and then you'll just be left with 24. So 24 is the answer. So k is equal to 24. And that's it. That's all of question 9. So that was by far the easiest part, one of the long questions so far.